The nuclear industry would appear to be one of the key solutions for satisfying the world's energy requirements without increasing the production of greenhouse gases. The treatment makes it possible to economize energy resources while reducing the toxicity and volume of the final waste by reclaiming materials contained in spent nuclear fuel that can be recycled. AREVA, La Hague site, world leader in high technology control, has emerged over the years as being a major actor essential to the nuclear industry. This site is designed to receive and process spent nuclear fuel originating from French nuclear power stations, overseas power stations, and research reactors.
Today, at 5:57 a.m. GMT in the security control station, the security officers are starting their 24-hour guard duty. A load of spent fuel assemblies are arriving at the Valognes rail terminal, situated at 20 kilometers from Cherbourg. They're protected by a watertight steel package called a chateau or cask. It weighs 110 tons for 10 tons of spent fuel. This positive strongbox is mainly designed to resist temperatures of more than 800 degrees Celsius and can be dropped from several dozens of meters. The road convoys between Valognes and the La Hague plant originate from one of the 58 French nuclear reactors, or reactors belonging to overseas electricity companies. One hour, 10 minutes after leaving the Valognes rail terminal, this unusual road convoy arrives at the La Hague plant entrance gates. In the receiving and dry unloading facility control room, engineers go about unloading a spent fuel assembly. This one assembly produces the energy equivalent of 27,500 tons of oil, which is used to satisfy the annual electricity requirements of 17,000 families.
"96% of the material contained in the cladding of this fuel can be recycled. 95% is uranium, 1% is plutonium, and only 4% is fission products or waste."
On the other side of these windows, which are 1.20 meters thick, the removal of the fuel rods from the assemblies is monitored from the control room. The assembly, still at a temperature of approximately 200 degrees, is cooled initially in water and checked prior to being placed in a basket. This basket will be set down in one of the 4 reprocessing site pools, the capacity of which makes it possible to store spent fuel having produced 5,000 terawatt-hours, which corresponds approximately to twice the world's annual nuclear electricity production. This 500 kilo spent fuel assembly is carefully set down at a depth of 9 meters. It will stay in the pool, where it will continue its decay process prior to being treated.
Meanwhile, a public relations officer explains the nuclear fuel cycle to a group of visitors. Close to 10,000 people per year come to find out about the activities of the AREVA La Hague site.
In the plant's control room, engineers carry out the actual treatment process by remote control. First of all, the fuel assemblies are sheared in accordance with an automatically controlled process. Only a few operating and maintenance operations require human intervention. These interventions are carried out by means of manipulators. Using remote manipulation, tools and materials can be handled by remote control, making it possible for the staff to operate under optimum safety conditions as they are never in direct contact with radioactive material. In the shearing facility, the cladding containing the spent fuel is cut up into segments. These 3-centimeter segments fall into a tank of hot nitric acid. The nuclear material is dissolved in this solution. The pieces of cladding called hulls are removed so that they can be compacted. The nitric acid solution containing the dissolved nuclear material is automatically transferred from the control room to the chemical separation facilities. Uranium and plutonium are separated and purified. The plutonium is recycled in the MELOX plant to manufacture new MOX fuel. This will feed nuclear power stations for further production of electricity. Since this plutonium recycling process was set up, it's been possible to economize the equivalent of the electricity consumption of the Île-de-France region for 6 years. That's the consumption of 11 million inhabitants. Uranium, on the other hand, is reused for manufacturing nuclear fuel or transformed into a stable oxide in order to build up a stock of energy materials. The final residue or waste is to be solidified here in accordance with an extremely safe procedure, vitrification. From the vitrification facility control room, the fission products are calcined and then incorporated in a glass matrix, trapping the radioactivity and preventing it from spreading. This mixture is then poured into stainless steel containers. The proven chemical stability of this borosilicate glass, which is used to immobilize the fission products, constitutes an international consensus concerning the qualities of this matrix. This solidification guarantees watertightness and stability for hundreds of thousands of years. Hulls and end pieces are compacted by means of a press with a 2,500-ton capacity. These materials from spent fuel shearing are compacted and their volume reduced to 1/5 of their size. The result? The treatment of 1 ton of spent fuel generates less than 0.4 cubic meters of final residue. Owing to the volume reduction, the surface area for final waste interim storage for 40 years of French nuclear electricity does not exceed that of a football pitch. This optimization also makes drumming safe and makes interim storage easier. Moreover, the use of standard containers makes the handling and transportation of residue easier.
The knowledge and technical know-how acquired here are internationally recognized. Consequently, 10 or so years ago, we established a close relationship with Japan. It is in this context that 100 or so Japanese students came for operator training to guarantee the running of their new Rokasho-Mura reprocessing plant in the north of Japan. It was built using the La Hague plant as a model.
French waste is temporarily stored on the La Hague site. As for waste from overseas spent fuel, it is returned to its country of origin in accordance with French law. There are approximately 4 to 5 transportations of vitrified waste that leave La Hague each year. The containers are subjected to a final quality check carried out by the specialists prior to being returned to the customers. On the other side of the world, in the north of Japan, a load of vitrified residue from spent Japanese fuel in La Hague is arriving at Rokasho-Mura. The La Hague plant activity has to show complete respect from the environment. To make sure of this, an 80-person team carries out 200 daily analyses of grass, water, vegetables and produce from the sea, in order to make sure that the treatment activities have no impact on the environment. The radiological impact of the La Hague plant on the population living in the vicinity is precisely calculated. It is less than 0.03 millisieverts per inhabitant per year. This corresponds to 1/100th of natural radioactivity. Consequently, 26,000 samples are taken every year from more than 800 different points around the AREVA reprocessing plant.
Lastly, in order to make doubly sure that there is no impact on the environment, AREVA's activities are placed under the control of national bodies. the French Nuclear Safety Authority, the French Regulatory Authority for Radiation and Nuclear Safety, which relies on technical know-how from the French Institute for Radiation and Nuclear Safety. They are also placed under the control of international bodies, such as Euratom, the European Atom Energy Community, and the IAEA, the International Atomic Energy Agency.
During this time, one of the roundsmen inspects a vitrified residue interim storage hall. Each circle on the ground corresponds to a pit holding 9 containers of vitrified products. Waste corresponding to approximately 5 years of activity by French nuclear electricity equipment is temporarily stored in the pits in this hall, under the roundsman's feet. All employees working in controlled access areas have to wear dosimeter film, which measures radioactivity in real time. Hands and feet are checked to ensure that they're clear of radioactivity every time a member of staff leaves the facility. Control equipment, preventive measures, medical monitoring, nothing is left to chance as regards the protection of the employees in the face of radioactivity. The La Hague reprocessing site, stretching over more than 741 acres, is permanently monitored by a team of 200 security officers, control systems, cameras, and electrified fencing.
Day breaks. Consumption of electricity in France increases at the same time, and today EDF power stations will consume a total of 7 fuel assemblies.
In the plant control room, the night teams go through their handover. More than 10,000 people work directly or indirectly for the site, a total of 20% of the local Nord-Cotentin workforce. In the security control station, the team changeover takes place quickly. The only thing worthy of note is our film crew.